Before we move on to a slightly more complex centerline exercise, I just wanted to spend a few minutes exploring the centerline concept of adding and subtracting corners from the floor plan to make it easy to calculate composite wall skin centerline dimensions from the inner girth dimensions. Let's have a look at this floor plan comprising a single 300mm thick wall. I have emphasized the corners for this exercise to make it easy to follow the method. Both the inner girth dims and wall centerline dims are shown, inner girth blue and wall centerline red. Follow this exercise carefully and you will never have a problem with centerline calcs and interior girth dimensions again. We will be using 2 by 1/2 by 300 as a way to dimension corners. So, quick revision, 2 by 1/2 by 300 means in QS speak that there are two halves of something, and that something in our case is 300. So each corner has two halves and each half is half of 300. So arithmetically 2 by 1/2 by 300 means 2 times half times 300, which equals 300mm. We will start at the base of corner C1 and trace a centerline path around the floor plan. We've agreed it's all about corners. So let's see how they change the inner girth dimensions, which are acting as our baseline for calculating these new centerline dimensions. At the top of corner C2, our centerline dimensions are the same as the inner girth dimensions. But as we have to travel round the corner C2, we have to add 2 by 1/2 by 300. We are adding the corner dimension to our inner girth dimension of 2.4. From the right side of C2 to the left side of C3, our centerline dimension is inner girth dimension of 1.9 less 2 by 1/2 by 300. But now we have to increase our centerline dim by going round the corner, so we now add 2 by 1/2 by 300. So the addition of 2 by 1/2 by 300 at C2 is now completely negated by the deduction of 2 by 1/2 300 at C3. C2 additions have been cancelled by C3 deductions, and if you look at the interior girth of 1.9, it is exactly the same as the centerline dim, i.e. 1.9 meters. Okay, let's move on. From the base of C3, we have to travel 2.5 meters less 2 by 1/2 by 300 to the top of corner C4. At C4, we need to go round the corner, so we add 2 by 1/2 by 300. We now head for the left side of C5, so we add 4.2 meters. At C5, we add 2 by 1/2 by 300 to get round the corner. Our journey from the top side of C5 to the underside of C6 is the same as C3 to C4, except in reverse. We have a negative deduction. The distance is 2.5 meters less 2 by 1/2 by 300 to the underside of C6. We now need to go round the corner, so we add 2 by 1/2 by 300 to get to the right-hand side of C6. From here, we head for the left side of C7 by adding 1.9 meters less 2 by 1/2 by 300 and adding back 2 by 1/2 by 300 as we go round the corner. From the top edge of C7 to the bottom edge of C8, we add 2.4 meters. Going around corner C8, we add 2 by 1/2 by 300. Finally, we head towards corner C1, so we add 8 meters. At this last corner, we add 2 by 1/2 by 300 to complete the total centerline dimension from where we started. If you've been following the tally, our total is 27 linear meters. Does this stack up with adding and subtracting corners? Let's do a bit more maths to find out. Our tally shows 27 meters. The floor plan has 6 outer corners and 2 inner corners. When we were doing our long-handed calculations, we found out that corner C3 cancelled out corner C2, and similarly corner C6 cancelled out corner C7. So taking out the 2 inner corners gives us 4 in total, and 4 corners is the same as 4 by 2 by 1/2 by 300, which equals 1.2. Our inner girth dimension is 25.8 metres, and 25.8 plus 1.2 equals 27.00 linear metres. So our corner concept does work. However, a mistake in internal girths or corner dimensions would lead to cumulative errors, so caution and accuracy are paramount. But this method saves lots of time and is more accurate, especially with multi-skinned walls. Our next example deals with floor plans that are not symmetrical. With this type of floor plan, which is not symmetrical and has unequal insets, the underpinning good practices are still the same. We use our corner concept as we did previously. However, because of the non-symmetry and unequal shapes, we have to be more careful with our walls and their dimensions. Ordinarily, with floor plan dimensions, we take the interior length and width and multiply by 2. But with unequal shapes, this is only partly the case. In this example, let's look at the lengths and widths. It can help if we mark up our lengths and widths as we go along. Arbitrarily, I have coloured lengths red and widths blue. Starting at the top left, we have interior lengths of 17.89, then 2 by 5.50, 7.29, 4.72, 5.89, and finally 2 by 7.62. Going widthways from top right, we have 6.7, 6.29, 2 by 4.00, 8.30, 11.79, 3.02, and finally 6.49. Our total inner girth is therefore the sum of the red lengths and the blue widths. This works out as 62.03 plus 50.59, which gives us a total of 112.62 metres. There are 10 outer corners and 6 inner corners. Subtract 6 from 10 gives us 4 corners to add. So our calculation of the centerline dimension of our 215mm brick wall is 4 by 2 by a half by 215 plus 112.62, which equals 113.48 metres. Our wall is 2.4 metres high, so the area of brickwork required is 113.48 multiplied by 2.4, which gives us 272.35 square metres. It is not difficult, we just need time and care to get the numbers right.